Hi Year 12. In this video we're going to walk through a titration calculation for some volumetric analysis. I'm taking a question from your textbook, page 51, activity 4A, number 1. Let's have a bit of a read. 25 ml of 0.400 mol per litre sodium hydroxide solution was placed in a freshly rinsed conical flask. Some phenolphthalein was added, that's our indicator. A rough titration with HCl showed that about 17 ml of HCl was needed for neutralization. 3 accurate titrations gave the volume readings 14.96 ml, 15.02 ml, and 15.00 ml. From that, we need to calculate the concentration of our hydrochloric acid. Let's work this one through. So first of all, we need to have a balanced chemical equation. We're reacting sodium hydroxide and hydrochloric acid together, so there's our balanced chemical equation for this reaction. 1 sodium hydroxide reacts with 1 HCl to produce 1 sodium chloride and 1 water. Let's write down what we've been given. Well, we've been given the concentration of sodium hydroxide of 0.400 mol per litre, and we've been given the volume of sodium hydroxide of 25 mils. Straight away I'm going to convert that into litres. That's our standard unit for volume. We've also been given the volumes of HCl, those 3 numbers, 14.96 mil, 15.02 mil and 15.00 mil. We'll come back to those numbers later. As we have the concentration and volume of sodium hydroxide, we can work out the number of moles that was present in our reaction. So, number of moles equals concentration times volume. Our concentration was 0.400 mol per litre, and our volume was 25 over 1,000 litres, giving us 0.01 mole of sodium hydroxide used in this reaction. We can see from our balanced chemical equation that every 1 sodium hydroxide reacts with 1 HCl. So if I had 2 sodium hydroxides, they'd react with 2 HCls, 3 to 3, 4 to 4, 0.01 to 0.01. So my number of moles of sodium hydroxide and HCl will be the same, assuming that the end point of the titration was reached accurately, where the same number of moles of each has reacted. So my number of moles of HCl is going to be the same as my number of moles of sodium hydroxide. I've done my times 1 over 1 fraction there. You can refer to my earlier video about that. But that's just demonstrating that I have got 1 mole of each, and that fraction can be used if it's not a 1-to-1 ratio, where you go unknown over known. So again, I've got 0.01 mole of hydrochloric acid and 0.01 mole of sodium hydroxide. What's my volume of hydrochloric acid? Well, I was given 3, 14.96, 15.02 and 15.00. I need to take an average of those 3, because they are concordant. Concordant means that they are close enough together to be considered accurate. If we were doing a titration procedure, you would need to keep on titrating until you get at least 3 concordant titers, which this person has done. So I need to work out the average titer value, or the average volume. So 14.96 plus 15.02 plus 15.00 divided by 3. Will give me my average volume of hydrochloric acid used. That comes out at 14.99 mils. Again, I need to convert to litres, so it becomes 14.99 over 1,000 litres. If I have my number of moles of hydrochloric acid and my volume of hydrochloric acid, I can work out my concentration. Concentration equals number of moles divided by volume. Number of moles divided by volume. My number of moles was 0.01. My volume was 14.99 over 1,000, and that comes out as 0.667 moles per litre. So that's how to walk through a calculation to find the concentration of an unknown solution from the concentration of a known solution.